Got to give the people. Get the people what they want. All right, Bass. All right, we're going to talk a little bit about a couple things. First off, representing polynomial graphs with number lines. So you want to get all this down in your notebook. All right, so I can represent a polynomial with a number line. Many of you were able to do this in last class. Some of you might not have quite gotten to it yet. But I want to make sure you have the notes. Remember, the bold parts show positive outputs of the graph that are above the x-axis. The open circles show the x-intercepts or the roots. You don't need to draw these arrows. I'm just drawing them to let you know where I'm referring to. And the thin, non-bold parts show negative outputs that are below the x-axis. So what I would like you to do is copy down this first example 1. I want you to copy down this number line. Then pause this right here and draw the graph that you think goes along with it. You just did it. Now I'm gonna do it. Okay, so I see I have intercepts at -5, -2, 0, and 1. I'm looking at -5, and on this side of it, it's not bolded, it's thin, so it's a negative output. So coming up, I guess I should go from farther. I have a negative output here. And then I'm noticing right in here, I still have a negative output, so it must be a double. And then I'm seeing at 2, I have an intercept. And now it is bold, and that means I need a positive output. So between 2 and 0, I'm going positive. And then at 0, I'm seeing after 0, between 0 and 1, my output goes negative. So I'm going here. I'm going to cross at 1. And after I cross 1, this is bold, so it should be positive. So it looks like it's going to go like that. So this is kind of what my graph looks like at this point. Why don't you do the same thing with number 2? Copy down the number line and then draw what you think the graph should look like. I'm just creating more space for myself. All right, so hopefully you did that. Let me draw my number line. I got something at -2, -1, 0, 1, and 2. All right, at -2, bold part shows me a positive. So I'm positive till I get to -2. This now shows me it's thin, so it shows me negative. So I'm negative at -2, and then I got to get back up to -1. At -1, past -1, this is thin, so it's still negative. So I got to stay negative until I get to 0. Because then at 0, it gets bold, which is happening right here. So on the other side of 0, it's bold and it needs to be positive, so it goes up. And at 1, it crosses. Then at 1, it's bold again. So I stay positive. And I got to get back down somehow to get to 2. And after 2, it goes thin, which goes negative, right? So I'm looking something like that. And obviously we don't know how high or how small things go, but we know if the parts are negative or positive. Cool. Write this next piece down. What the degree of a polynomial tells me about a graph's behavior. Okay? So what I've learned is, boom, 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 if you have an even degree, the graph starts off positive, like y equals x squared. And I actually use these to think about this all the time. Like everybody should know at this point that y equals x squared is a parabola, and we'll see that this thing starts up here in a positive place, right? So even degrees, anything that has an even degree, squared, fourth, sixth, they should start off positive. Now here, if you have an odd degree, the graphs should start off negative. And again, I just think of one that you should know, y equals x cubed, right? A cubic. Cubics look something like that. And that actually is kind of messed up, but I know it starts at the bottom and it goes up, right? So this one starts down here, which is negative, and it is an odd degree. Cool. So you just want to make sure you have use those two examples to help you if you forget which is which. All right, we are almost done. This one isn't too long. Leading coefficient. What is the leading coefficient going to tell me? So, the leading coefficient is going to tell me two things. First off, if I have a negative in front of the leading coefficient, it will flip the orientation of the graph. In other words, it changes where the graph starts. So, right, y equals x squared. If I put a leading coefficient in front of it that has a negative, it's going to flip it so that it becomes something like this. It flips it where it's an even degree, so it should start positive, but I put that negative in front of the leading coefficient, so it becomes negative. Okay? So now, oh, I had it right there. Huh, I should have put it right there. I set myself up so pretty. Right? So y equals negative x squared looks something more like that. Ugh. Just kidding. Looks something more like that. Okay? So then, if I put a negative, so here, this is an odd degree. This is x squared. So this is actually a third degree term, right? If I have x times x plus 1 squared, it looks something like this. And if I put a negative, like a negative a value, a negative leading coefficient in there, it's literally gonna flip it. So it's gonna start here. Ugh, that's ugly. It's gonna start up, go down, come up, and look something more like that. Again, that's ugly, and it's probably not exactly correct, but point being that it went from starting negative and it flips it over so it starts positive. I had the drawing somewhere, and I don't have it with me right now, so that's the best I can do. It's kind of ugly, though. Okay, anyway, let's finish this thing off. The other thing that the leading coefficient tells me is it either stretches or compresses the graph, which this you already know. Like the a value stretches it. So if you have like y equals x squared and you put a 2 in front of it, it stretches it out so it's longer. Or if you have y equals 1/2 x squared, it compresses it so it's shorter. So right, this one stretches so it's longer. And this one compresses so it's like shorter. Okay? So that's what you got to have. Those are the things that you need to know. Some of these drawings are kind of suspect. Suspect. Super suspect. This one is actually decent. But point being, you guys know the idea and you've seen the stretch or the compression already, so I'm not super concerned with that. All right, you guys, that's what I got. Have a good day. Get this stuff done. We'll finish up these next challenges in class. Thanks.